Hey everyone, happy Sunday. Well, I'm shooting this video on Sunday, but it's probably gonna be like a Monday when I release. But today I'm gonna do a speed round on LeetCode. I'm gonna try to do 10 questions as fast as I possibly can. I just picked 10 random questions out of blind 75 list, and I've done this list before, so I kind of know the answers to a lot of these questions, but I haven't really done LeetCode in about 6 months, so I'm probably going to be rusty. But let's see how fast I can do these 10 questions. Hopefully, I can do them within 30 minutes. They're mostly easy and a few mediums. Um, yeah, let's just hop into it. If I'm not talking, it's because I'm trying to solve it fast. Let's just put a timer for like um, 40 minutes. And if I can't finish these all in 40 minutes, I'm just going to quit. Hopefully I can do it faster than that. The first one is the classic two sum. So I didn't know how to solve this one. It's pretty much return indices of the two numbers such that they add up to the target. So pretty much how there's exactly one solution. So pretty much what we want to do is, since there's only one, so basically well, I have to talk fast because I need to solve these as quick as possible. But yeah, I'm just gonna solve this because I already know. We just have to store the current value minus the target, which is like opposite equals, and then we'll probably put in a map for in nums, and I'll put the index. I gotta solve this fast as possible, so I can't even explain the answer. Maybe I'll I'll do that in a separate one. Opposite equals, you say target minus the number equals index, because we have to return the indices. Okay. If opposite, so we'll say if the target, if target minus num is in opposite, return the current index, and otherwise, yeah, I think that's good. Where'd it go? 9, no. Target minus number, target minus num, if it's an opposite, return the index, and an opposite. Okay. So we have 2. When we see the 7, we have to return 9 and 1. So we take 9 minus 2. Ooh, this might take me long. If I'm struggling on two sum, this might take me longer than expected. Okay, let me debug this. So it should, let's print out the map at every iteration. No, I'm gonna make this bigger. 7, 0. But okay, 7. Where'd it go? Target minus num in opposite. Okay. So debug this fast. Target 9. The number is 2. Target. If target's in opposite, what does it mean? target num target minus num 9 minus 7. Oh, okay. We just have to store the current num. Alright. Because then now we're looking for the opposite. Shoot. Oh no. I might have to buy LeetCode Premium in the middle of this. Please, please. Okay, one down. Took 5 minutes. Given an integer, return true if any of the values appear at least twice in the array and return false. Okay, so I'll literally just return false here. For, scene, create a scene set for num in nums. If num in scene return true, and then we'll put scene dot add num. Gonna do the easy ones. Cool. Number of islands. We literally just have to count the number of islands here. Let's see. Go 0. Return num islands. This is like a simple depth first search. Self. So say scene. Usually with depth first search you have a scene array for num in nums, or sorry, for row in range like 0 to, or sorry. Okay, I'm gonna loop through the rows and the columns. Call in range. Okay, what are the rows again? The rows is just the length of the grid, and then the columns is just the length of a specific element. So I'll grab grid 0, or sorry, for length of the grid at 0th. If I'll store pairs if row column is in scene, continue. Otherwise, we'll do a depth first search, pass in the row and the column, and then we'll increase the number of islands by 1. Row column scene. Usually what you'll want to do, scene.add the row column. Then we're going to do our depth first search, which will be after I add it. What will I do? I have to look at my neighbors. We'll do stack for depth first search. Stack row column. I'll do while stack has any elements. We're gonna do the candidate equals stack dot pop for, I'll say the cat we're storing like the row and column here, so I'll store this for neighbors. I'll make a neighbors array. I'll literally just, we have to look at like top, right, bottom, left. Damn, there's a lot of code to write. Okay, top -1, column +1, row +1, canned row. So canned row -1, canned column +1, canned column -1. Cool. That's the neighbors for row. Still want to make this code a little bit readable. For name row and name columns, if these are already seen, continue. If these are already seen, continue. Otherwise, if, oh, I actually have to pass in the grid here probably. Yeah. If the grid how much time? Oh, we're almost at 10 minutes. Not equal to 1. If it's not part of an island, we shouldn't go there. And otherwise, stack dot append neighbor column scene dot add neighbor row neighbor column, and that should be good. If neighbor not equal to 1. Okay, I need to check the bounds. Sorry. If name row is less than 0 or name row is greater than equal to the length of, if name is greater than equal to the length of the grid, or the column less than 0, or the column is greater than equal length of the grid columns, continue, run. Answer 12. Interesting. Number of islands. What happened? If row and column in scene, we pass scene in here. Row column. Okay, after this first scene, we should have like a bunch in scene. How much time does scene print? It should only print once. What, print again? What's happening? Print here, row and column. Print here, row and column, 0, 0, 0, 4. Oh, sorry, I have to check the grid here. Submit. 3 down. You can see I don't do these questions a lot. Last time I did it was in May. You're climbing a staircase. It takes n steps to reach the top. Each time you climb, you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? What is the constraints for this question? Can you start at 1? Wait. Okay, so for each step, you have to add up how much it could. Okay, cool. Result equals for I in length n. You start at the first step, and then we'll return result. Wait, return last element. Return last element. of array in Python. Yeah. Climbing stairs, return, result, -1. What I'm gonna do is everything starts at 1 for I in length 1. Print. So the first one we have firing range n. Honestly, so for 2, what we're going to do is we're going to take the second element. There are 2 ways to climb to the top. There are 2 ways to, oh, if it's 2, why is it 2? There's 2, what are the main ways to get there? You could, there are 2 ways to climb to 2. 1 step plus 1 step. Okay. The 0th counts. I didn't know the 0th counts. The 0th step counts. Like you start on the 0th step. So you could take 1 step and another step, or you could take 2 steps. Okay, cool. So let's just start this. So I'm literally gonna so for 3, let's look at this third case. Yeah. Okay. Let me. This is gonna take extra space, but it's all good. For I in range n plus 1. What I'm gonna do? Because to get to each step, you could either get there from 1 step or 2 steps. So do 2 step. 2 steps equals result -1. Result equals let's call this current index -1, then -2. This is gonna index out of bounds, so usually you do like if what I like to do. If the current index -1 is less than 0 or greater than equals 0, then I'll say result at the current index equal to one step. I could have either got there from 1 step or 2 steps. Trying to literally do this as fast as possible. Expected if ternary op. Is this not a ternary operator? If greater than equal 0. There. That's a proper ternary operator. 0. Why are we all getting 0? If the current index -1 is greater than equal to 0 plus okay, we start on the 0th step, and then we're going to the n plus 1 step plus 1. 0, 0. What's the answer here? 0, 0. Why is it all 0? Current index. If the current index -1. Okay, let's just do this. Print 1 step, 2 step, and the current index. And then also the result. Oh, okay. Actually, no. What is this? Okay, 0, 0. I think we have to add +1 here. Because we can get to like plus extra step that way. Okay, what do we get here? +3, +6. Wait. Okay, I think we just need to pre-fill the array. We need to, for the 0th step, there's 1. There's 0 ways. For the first step, there's that way, and then we return n. So n is the second. 0, 1, 2. Okay. This way there's 2 ways, because you can just jump here, or you could just jump here, and then that's 1 way, or you could just jump straight to it. So the other ways are going to be minus. Okay, we don't even need to do these checks. If n is less than equal to 2, return result n. Otherwise, we'll do this n plus 1 step, 2 step, you see I haven't done these questions in a long time. Literally I would not be flopping like this. List assignment out of index, current index. What the heck? Result. Oh shoot, I need to add more to result, sorry. Let's just make result a bit bigger. While the length of the result is less than n, print result. Okay, print brief. Index. Sorry. We start at 2. Or sorry. We start at 3. Okay. What did it return? 2. List assignment out of index. Current. Okay, wait. If n is less than equal to 2, I'm pretty sure I should have returned that. Okay, did this test case work? Okay, wait. Let's see. Did 2 work? Okay. Now let's scale it up to 3. Holy, time is cutting short. Oh no. I might have to sign up for LeetCode just to get this to pass. Please work, please work. Okay, I just had to hit those edge cases. Merge intervals. Oh my gosh, it's a little bit harder. I'll make that my last one. Okay, I finished number of islands. I finished climbing stairs. Binary tree level order traversal. These are just classic. Return to level. Okay, I just need to traverse this tree level by level. Result. Return result. See from collections, import DQ. Do I have to return the actual node or just the values? Return the level of its node values. Okay. Level order traversal, you usually do like 4 in range of the length of the queue. candidate equals q dot pop left. We're using q here. Then we're taking, then we're gonna take candidate q dot pop left. Then we're going to take the value. Add it to temp.res dot append. This time is getting tight. I might have to. It might be 10 questions in the span of an hour. That's crazy. Temp.res dot append. And the value at the end of that, we'll say result dot append temp.res. If can dot left, then we do q dot append can't. If can dot right, do q see if that works. I literally have no room for error with this much time left. Okay, 4 down. Reverse a linked list, classic. So usually we'll have a sentinel node. Let's see, how do I do this? We have a head and we point it at the sentinel node. Okay, yeah, we have a sentinel node. We'll create a sentinel node or left or yeah. No, do we want to create a sentinel node? Okay, let me just draft this out quick. It'll be faster. 1, 2, 3. Then we'll do have a pointer here, pointer there. Okay, I'm gonna just extend this by 20 minutes. I feel like I'm getting really close, but let's just do another 30 minutes. Hopefully I'll get it done, and we'll see how long this actually takes me at the end of the video, but I don't want this thing to go off while in the middle of. Okay, so we have a 1, point at none. Okay, left, right, none, head. We make head point to none while head, or sorry, while right pass, return left. So what we're gonna do is we're gonna make our right point to our left, right? Or no, we have to store temp equals right dot next. Then we make right dot next point to our left. Then we make our left, we move up our left equal to right. And then we make right equals temp. Okay, update the pointers. Dude, I do not want to fail that. When's the last time I did that? March. Yeah, maybe 5 months ago. Linked list cycle. See if given a head of linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there's some node in the list that can be reached again by continuous. Okay, return true. So usually you do this by doing like 2 pointers, one that's moving fast and one that's moving slow. So I'll do a slow pointer, then I'll do a fast pointer, and I'll just put them both at head. Then I'll be like while fast. Okay, while fast still exists, I'll do while fast exists and fast.next exists. I'll say fast equals fast.next, and I'll do the slow equals slow.next. If fast equals slow, return true. So you do 2 pointers, one moving fast. If one catches up to the other, you return true. That's usually the most optimal way to solve this question. Cool. All right, 3 more questions. Maximum depth of a binary tree. Interesting. I could probably just do this with binary search. Let's see. But let me just do a level. Let me just do like a post order traversal. So what I'll do is I'll say depth of left equals, okay, basically if it is none, return 0. Basically that's the base case. If root is none, return 0. If root is none, return 0. Then I'll do like, I'll calculate my max left equals self dot root of root dot left. Max right equals self dot root dot right. Now return the max of left, the max of right, plus 1. So maximum depth, doing a post order solution. Root doesn't exist. Oh, shoot. Self dot max depth. Calling this function. Starting to get hungry. I think I'll be able to solve these within the 30 minutes. Is same tree. We're just seeing if they're the same tree or not. 2 binary trees and not if they have the same value. So I'll literally try to zip these 2 trees together. Given that roots, check if they're 2 binary, if they are structurally identical. Interesting. How do I do this again? Okay. I mean, we should just pass them both at the same time, and just start comparing the nodes. Like if root is, so these are the cases. If P is none and Q is none. Okay, they're the same tree if they're both none. That's one case. If P is not none and Q is not none, and I'll be able to talk a lot more and explain stuff when I get more ramped up on LeetCode, because it's just been a while since I did this. If the P is not none and Q is none, I'm just doing this a speed round. If P is not none and Q is, false. Else elif Q dot val is not equal to P dot val, return false. Else return, that means they're equal, then we just literally return is same tree. But we have to do a post order. So we have to check if my left equals self dot, dude, there's a lot of code for P Q dot P dot right, Q dot right, return left and right. Those all have to be true. Just a little simple post order. Please work, please work. Nice. Merging intervals. This is my last one. I just need to merge these intervals. Given an array of intervals where merge all overlap and return an array of non-overlapping intervals that cover all the intervals in the input. So we have these intervals, and we just need to like merge them. Are they sorted? No, they don't say they're sorted. When's the last time I did this? Literally 9 months ago. Merge all overlapping intervals and return an array of the non-overlapping intervals that cover all. Okay, we just need to merge the intervals. So I think we just need to sort them by start time and then just start merging them. Let's do intervals equals sorted intervals. How do I define a function for? I'm pretty sure it's the second parameter. Define sort for sorted array Python. How do I do this? Does sorted take a second element? Okay, sorted function, iterable key equals, let's do key. How do you do key sorted? Okay. For sorted in Python. Okay, nice. We can pass in a lambda function for the key. And then, because I just want to make sure for lambda enter for key lambda enter, I'm going to sort by the zeros. Nice. Because it didn't say it's sorted. So cool. Let's just loop through for nodes. Now that it's sorted, we just need to compare one after the other, and then merge it with the one behind it if it overlaps. For I in range length of my intervals, if I equals 0, continue. I'll just make a new one. Result dot append intervals of I, and then continue other, and then what we'll do is if I equals 0 or let's do this. Index, we'll enumerate through them. Enter in enumerate intervals. We'll do, if the index equals 0, add the index. If the index equals 0 or the interval start time is greater than, what's overlapping? Overlapping merge. Okay, if it could also equal, less than equal to result, the last element there. If it's greater than, if the current element start time is greater than the last element's finish time, then we just append it and just continue. Otherwise, we have to merge them. So we take result -1 is equal to -1 equal to 2 elements, which is, or we just kind of have to update the first start time or the end time here. And what we're gonna do is we're gonna take the max of like the current interval we're looking at and the last end time. Let's see how long this took. So 7 easies, 3 mediums, I think, and I think I landed that in under 30 minutes or around 30 minutes, but cool. Thanks for watching me LeetCode. I just solved 10 questions in under 30 minutes. And yeah, hopefully I can get faster and faster. I'm getting back on LeetCode. It's been like 6 months since the last time I touched LeetCode. So cool. Have a good day. See ya.